guys, welcome again. So sorry, it's been too long time since we started this series of the DC voltage and current measurements. If you remember, it's been like very long time where we released the first part, which is the introduction of these two parameters, which is very important parameter measurements, which are the current and voltages. So sorry for that. Today we will continue with the second part of this series where we will talk about the voltage. So in this part we will talk about the first quantity measurement, which is the critical quantity measurement, which is the voltage. So as you remember in this first part, which I really recommend you guys to go through and watch the video, is really informative and got a lot of things that shared in that video. So yeah, in this video we'll focus on the voltages, how we can measure the voltage, the DC voltage using the external MCU. For sure we'll focus on Arduino or Raspberry Pi, but mostly I'll go with Arduino. And we will learn how we can measure a different range of voltages. Let's say here we have an example of an actual multimeter. For example, we have the range of 10, 20 or 100 volts magnitude. Yeah, so we will go through this part first. Then in the future we will talk more about the current measurements. Okay guys, so let's do it. Okay guys, so let's say we have a voltage source here. Let's say we have a battery. Okay, let's select the pin. So let's say we have a voltage source. So this is the ground and this is the voltage source. So if you want to measure the voltage at this battery, so what we can use is just a multimeter. Okay, this is our multimeter. We set the COM, this COM, what they call pin to the ground. Sorry, to select again. I want my okay black. So the COM will be going to the ground, and the second lead, which is the positive, will go all the way. Why like this? Okay, so this one will go all the way to the point where we want to measure. So if you can see here, actually we're just connecting the voltmeter. This is the voltmeter. We connect it in parallel to the voltage source. Okay, so now if I want to measure it using the Arduino or any other MCU, so we replace this guy. Oh, it's okay, just keep it there. I'll change maybe to, let's say, blue. Okay. So let's say here I have my MCU. This is my Uno. So in Uno we have a very good peripheral called ADC. This ADC is analog to digital converter. Okay, so which is converting any analog input. Okay, any analog input, any input, but it should be all in positive, no negative part. Any analog input, it will convert it into a 10-bit digital output. Okay. So we connect this guy. Let me take here. Okay. So we use this ADC that's come with the Arduino. By the way, the Arduino Uno come with 6 channels. Okay, ADC, each with 10 bits. Okay, so we have 6 channels that I will show you in the picture. We have from A0 to A5, named A0 to A5. Okay, so again, same what we did in the multimeter. We just connect the Uno in parallel with the voltage source. So again, we have ground. We connect this guy to the ground, and we take the ADC pin, we connect it to the voltage source like this. Okay, so this the Arduino able to read the voltage source value converted to the digital using the ADC. Then we can bring it using, for example, LCD or the serial monitor, let's say using the PC. So here we will use the USB. Here is our USB port. We can connect this guy to our computer or PC to display the value or the final value of this. Okay. We have one small issue here, which is the maximum value this ADC can measure. Let's change to the light blue. So the maximum value that this ADC can measure is 5 volt. Actually, it depends on the V reference. There is one pin on the Arduino. They call it VREF. This VREF is help to increase the accuracy of the ADC. Plus will limit. It's not plus actually. Is a cone that it will limit the maximum value can measure by the ADC. So anyway, let's say we are using internal voltage reference, which is 5 volt. The internal reference of the UNO is a 5 volt. Okay, and we are not using the external reference. So the maximum voltage, at ADC, it should be 5 volt only, which is equal to the VREF. We can't exceed it. Okay, if exceed, we might damage the ADC or might damage the UNO overall. So what we can do, okay, what we can do to make the Arduino, our MCU, we give it the ability to measure more than 5 volts. Okay, it's very simple and easy. We can just use a voltage divider. Okay, so let's say if we take directly from here, the maximum will be 5 volt. If we use a voltage divider, 2 resistors, this one go to the ground. Now the signal to the ADC, we take it from here. Okay, so if I delete this guy, now I will connect the signal from this voltage divider. Now with this voltage divider, I can manipulate the output voltage or the V divider, okay, by reducing the voltage so that I reduce it in the range of the working limits of the UNO, which is 0 to 5 volt. Okay, then we just need to calculate the R1, R2 using the voltage divider equation, which we will discuss about later, and we will lower down the VR. Let's say this V battery, okay, let's say is equal to, let's say, 12 volts. So with the voltage divider, we can reduce it let's say to from 0 all the way, let's say 5 ohm. We don't want to go to 5 volt. If something happens, let's say to 4 volt. Okay, by using these voltage dividers. So this is how it could be to measure the voltage from a voltage source, let's say a battery. Okay, let's have a pointer. Is it this one? Nope. Anyway, I guess this guy here. Yeah. Is it this one? Nope. Anyway, so yeah, this is how we will do it. So later we will see how we can vary this value, okay, with different values. Let's say 12, from 0 to 12, maybe we can use 0 to 24 volts, okay, but at the same time we will change this resistance. Maybe we will use another divider go to the ground. Okay, another divider. This divider might be a different value. Let's say this one also go here. This might be a different value. Let's say R3, R4. So this one will be a different values. Okay, that will give you a different range. So for example, 12 volt will become to the first branch. The 24 will come to the second branch. Okay. So again, to make this clear, sorry, it looks messy now. Let me bring it up. So what we will do, we will try to design the voltage divider circuit inside the Arduino. So we have this Arduino. Okay. We have what else? We will design, let's say, two voltage dividers. Let me change the color. Green as what we used last time. So we have like, this is the first voltage divider. We go to the ground, and here is another one. Again, go to the ground. So these two will be the V input, V in. Okay. And here we will have the output will be one here and one here. Oops. Oh, sorry, let me delete this thing. So delete, is it like this? No. Okay. So we have 1 point here again and 1 point here. Okay, so we have these 2 points, one here, one here. These 2 points we will have a switch to switch whether we need to connect to this point or we need to connect to this point. And this one will go to our ADC. Okay, then we have our ground, black. So this is go to the ground. Okay, like this. So then we will have only one wire. Let's say again, this is our battery. No, we want this. Okay, so we have our battery here. This is again go to the ground. Okay, so we have, this is the V battery. So now with this, we have only one connection to the V battery. Then we have here selector, so the range will be following this switch here. So for example, I need like, okay, this guy here. Okay, so we have, if this switch is connected to this point, so it will connect to this range. Let's say this range, it will measure from 0 to 12 volts. Okay, then we need to calculate these two values. Or if we change to another branch, or if we change to another point, so it will be connected to this voltage divider, which will be converting or will be covering the range of 0 to 24 volts. Okay, so this is actually the concept of the multimeter, by using different voltage dividers that covering different ranges of voltages. Okay, so yeah, it looks cool now. So I believe we are ready now to go and have some hands-on circuits and do some measurements, and we see what we can get. Okay, let's do it. Well, guys, so now we will start with the first part of the video, where we will measure only 0 to 5 volt. Okay, so the first part will be 0 to 5 volt range. So since we have 0 to 5 volt range, and as we know, our Arduino, we said just now, it can support 0 to 5 volts. So what we will do is we will connect, this is the ground, we connect our Arduino directly to our source. Let's say this is, we have battery, but for sure I will not use battery, but I will use a variable bench power supply. So this is a variable one. Okay, and I will draw my input will be like this. Here we go. So this is the ADC. Here is the ADC. Okay, so we will implement this circuit. It's very straightforward because our range will be from 0 to 5. So this is the first thing we will start with. And since this guy here, the Uno, can support 5 volts, so we can just use straightforward without any voltage divider. Okay, then we will vary our voltage here at the input from 0 to 5 volts. Okay, so you can see here I have my DC-DC regulator or buck-boost converter, so I can regulate the voltage to the Arduino, and I have my processor, which is Arduino Uno. That's the output of the DC-DC converter connected to the A0 of the ADC, which is the first channel of the ADC converter in the Arduino Uno. And also here I connected the multimeter so I can see what is the actual voltage being injected to the ADC. Okay, so from here I can change the voltage so we can see what is the readings from the Arduino after it's calculated the ADC. Okay, let's do it. So first I will open an example. I'll start with an example of ADC reading, which is the analog reading to serial. Okay, cool. So I'll start with this guy. So this one, where to start? Okay, we just will upload this directly to the Arduino Uno and see what it will behave. So okay, and upload. So this one should return the ADC value, the raw ADC value from the analog channel 0. Okay, so expect the value from 0 to 1032. Okay, so done. Open the serial monitor. I will see some numbers here. Here we go. So now about 200 something, can see here on the serial. So now I will try to change the voltage, then we see how it will be changed. So I will go down. You see now we are supplying 0.8. With 0.8 the output is, or the reading is 160 something. Now I will go up all the way, try to reach the 5 volts. You see now 2.7, reach 500, it's about halfway. 3, reach 6 something. Almost 5, we don't want to accidentally exceed it. And then we will damage our ADC. And here we go, let's say 4.9, let's say 9.8, more than enough, good, close enough. And here we go, you can see like 1023. Okay, that's good. So now we can get, let me bring this down. So now we can see this is the only ADC reading. How to convert the ADC reading into voltage readings. So from here, let's define a float. Let's say voltage equal to sensor value. We multiply it by the VREF. VREF here is 5 volt, 5.0, and divided by the resolution or the full scale, which is 1023.0. So this is the equation that written as the, or calculate the voltage. So I will bring the voltage now. Let's bring here, let's add some delay. So I don't want to be very fast. Okay. So this is the voltage calculation. Voltage calculation. Okay, it's uploading. Done. Thanks. Okay, let's see. So now we see 2.5 volt, 2.52 volt, 2.5 something, exactly what we are measuring here. So I mean, very close enough. But what I want to do, I want to add some loop here to take more than one readings. So what I will do is
let me put it here. So I will say, let's say byte samples. This is how many samples we want to take. Let's say I want to take 16 samples. And also I want the float accumulator that will keep accumulating the data here equal to 0. Okay, so what I will do is I will loop for 16 times. It's just like I loop for the same amount of the samples to collect the average of them. So 4 bytes, let's say I have counter I equal to 0, and my I will be less than equal than samples. Okay, then my I will be increased by 1, open bracket. So I want to add this one here and this one also. So these two will be here, and at the same time I want to add the accumulator. So the accumulator will be plus equal the voltage. Yeah. So I will keep adding the voltage to the accumulator to take for 16 times. Then at the end of the day, before I print it out, so I need to divide by accumulator divided by the number of the samples. Yep. So I believe, oh no, sorry. We need to do something else because this one will take it out. So after I print out, I need to clear the what they call the accumulator. So here the accumulator should be equal to 0. Okay, I believe that's it. So this one will be equal to 0, so it will be ready for the next cycle. Voltage, yeah, there's something, it should be voltage. Okay, it's uploading. And done. Cool. Okay, let's see the serial monitor. So now we can see the readings kind of more stable. Now you can see more offset. Let's say, and here we are putting 2.5 but we're reading 2.6, so that's why we need to calibrate it. Okay. So to calibrate it, we have two ways of calibration. So first we will go with a single point calibration. Well guys, so here I draw some line for you guys to understand the single point calibration. Okay, so let's say here is our data. Okay, this line representing our raw data before calibration. Okay, the raw data measured. But from the multimeter, for sure, this is our reference will be the digital multimeter. Okay, the DMM, digital multimeter, show us that this is the correct value should be in this area. Okay, so what we can do is we find a single point, let's say in the middle, then we find the difference, okay, between the red value or the actual value, okay, the one we got from the Arduino ADC and the value measured by the DMM. We found this difference, then we apply to our curve. So the uncalibrated value or the measured value will be matched to the calibrated value. Okay. So in this case, for example, take something in the middle, but sometimes, for example, for me, I might take like another point here, okay? Maybe another point here and here. So I have three differences, okay? Three differences from point 1, point 2, and point 3. Although it's a single point, but it's still a single point. We won't take the whole curve. How can I say? I mean, later we will see what's the difference when I talk about the 2-point calibrations. Okay, so these 3 points Then I will take the average, AVG, okay, the average of these 3 points. Then I will use this single point again as the average of these 3 points into my equation. Okay, so this is how it works for the single point calibration. Okay, again, we are having a single, where we can see our what they call the raw data that we measure is in the same slope as the actual data or the correct data. Then we can have just a single point to calibrate it or to bring back the uncalibrated data to the calibrated value. Okay, so something like this. So now we are ready to go and implement it in our code. So now let's implement the single point or 1 point calibration. So first, what I will do is, let's say, okay, we start from 2.5. Let's say now I will apply exactly 2.5, almost there. Okay, so yeah, I already injected 2.5. Then we can see the reading here is 2.67. So to find the factor, so let me put it here. Let's say is float calibration factor, okay, equal to. Before that, let's drive the equation. So the equation is calibration factor. Let's put this as a comment. Is equal to the what they call the DMM readings minus the MCU readings. Okay, so now the DMM reading should be 2.5 minus the actual reading from the MCU is 2.67. Okay, which in turn that one will be equal to 0.17. Okay, but this one for sure it should be in minus 0.17. So our factor should be, let me comment this, minus 0.17. Okay, but this one where? This one at 2.5. Let me change to, let's say, 1 volt. Almost there. Okay, 1 volt. So you see down there around 1 volt almost match. So at 1 volt, the DMM reading is equal to 1.0 minus our reading is 1.078, let's say 1.7. So that will be equal to about 0.07. Okay, so now let's go up all the way to 5 volt and see what is the reading. This one at 1 volt. This one at 2.5 volts. Okay, let's go. Let's go all the way to 5 volt. you see here, I just injecting like 4.6 and we're reaching to 4.9 in the ADC. So I don't want to go higher. I will stop maybe at 4.5. Let's say 4.5. I'll go down because this one, if I inject, for example, 4.5 volt might go higher in the ADCs, which is wrong. So I will go down to 4.5 reading in the MCU, around that. Or to make it nice, we just go for 4 volt in the DMM to make our calculation easier. Yes, 4 volts. So at 4 volts, the DMM reading is 4.00 or 4.0, whatever, minus. Our MCU reading is 4.253, let's say 4.30. So from that, we can see the difference is about 0.3 volts. Then I'll take the average of these three. Okay, this is at 4 volts. At 4 volts. Okay, so the average is about 0.18. Okay, which is in minus for sure. So here we go. So the average will take it as a calibration factor, so 0.18 average. Okay. Now, what I will do, I'll just add on the calibration factor to here. So first I will divide by the samples, then I will add it to the calibration factors. Okay, let's see. Let's upload our code and test again. There we go, close enough. Close enough, looks nicer. Okay, so let's go down. You see now, I'll go to, let's say, 0.8. Yeah, 0.8 for sure. You can have 100%. If you want 100% match, we need to go to the, or higher accuracy, I can say we go to 2 points, but 1 point, this is more than enough. Let's say 0.8 and we go like about 0.6, 0.7. So if I go to, let's say 1 volt, try to get it to 1 volt. Here we go, let's say 105, 0.9, looks good. If I go for, let's say 1.5 volt, almost there, 152, 14, okay, like 0.1, 0.08 different, looks acceptable. 2.2 volt, 2.2 looks nice. 2.6, still 2.67 something, also acceptable. There we go. 3 volt, 3.17, 3.18, 3.2. If I go all the way, let's say to 4.2, here we go for 4.25, get 4.3, which is 0.08. So 0.05 different, looks okay also. Now I can say if I go to 4.8, reading is about 5 volt. Now we can see about 0.2 or 0.14 different with 100 millivolt, but it looks okay. Okay, that's good. Yeah. So yeah, this is how we can implement the single point calibration. For sure, you can expect very high accuracy from a single point. Otherwise, we need to go for 2 points calibration, and this is what we will discuss next.